Commodities can be stored using a variety of methods, whether that's palletized, solid piled, in bin boxes, on shelves, or in racks. But regardless of the physical method we use, the storage configuration generally falls into one of three main categories: miscellaneous, low-piled, or high-piled. In this video, we will focus on understanding miscellaneous and low-piled storage, what sets them apart, and why these classifications matter for our facility's safety and fire protection. When we look at NFPA 13, for storage to be officially classified as miscellaneous, it must possess all four specific characteristics. Let's break them down one by one. First, the storage must be strictly incidental to another occupancy use group. To truly qualify as miscellaneous, the storage has to be secondary to the primary purpose of our building. For example, if we operate a custom furniture shop, our building's primary purpose is cutting, assembling, and finishing wood. A small designated area where we store raw lumber or hold finished chairs before shipping is merely a secondary function to support our fabrication process, making it incidental. Second, our storage height must not exceed 12 feet. To determine this correctly, NFPA 13 specifies that we must measure the storage height from the floor level to the very top of the commodity. It is important to note how we apply this to rack storage. We shouldn't only account for the height of the highest part of the rack structure itself. Instead, we must also consider the height of the load sitting on that top level. Our true storage height is defined by the very top of the highest stored item, not just the metal framing. Third, the total aggregate storage area cannot exceed 10% of our building area or 4,000 square feet of the sprinklered area, whichever of those two numbers is greater. These specific limits have clear origins. The 10% limit is pulled from accessory use definitions found in model building codes like IBC. Meanwhile, the 4,000 square foot limit is calculated by taking 10% of the maximum allowable area of coverage for a sprinkler system riser that protects high-piled storage. Imagine our total building area is 30,000 square feet. If we calculate 10% of our building area, we get 3,000 square feet. Because NFPA 13 allows us to use the greater value between that 10% calculation and 4,000 square feet, we are permitted to have up to 4,000 square feet of miscellaneous storage in this building. Now let's say our building is larger with a total area of 60,000 square feet. Calculating 10% of our building area gives us 6,000 square feet. Since this value is greater than the 4,000 square feet baseline, we are allowed to use up to 6,000 square feet for our miscellaneous storage. And fourth, our individual storage piles cannot exceed 1,000 square feet, and we must separate each storage pile from the others by a distance of at least 25 feet. This rule is designed to act as a built-in fire break. By limiting the size of a single pile and enforcing a strict separation distance, we ensure that a fire is much less likely to jump from one pile to another. This containment gives our sprinkler system the time it needs to control or suppress a fire within a localized area before it can spread to the rest of the facility. Now that we understand what constitutes miscellaneous storage, let's review the requirements for our hydraulic calculations. When performing hydraulic calculations for miscellaneous storage, NFPA 13 generally equates the storage risk to an ordinary or extra hazard classification based on the commodity class and storage type. Table 43171 outlines design criteria for Class 1 through 4, Group A plastics, tires, and rolled paper. Let's look closely at the data for Class 1 through 4 and walk through the columns of this table from left to right. First, we have the commodity column, followed by the type of storage. Next, we see the storage height and the maximum ceiling height, both listed in feet and meters. Moving further right, we find the design criteria referenced from section 192311, a column indicating whether an in-rack sprinkler is required, the required flow for inside hose, and the total combined inside and outside hose demand in both gallons per minute and liters per minute. The final column establishes the required duration in minutes. We can conceptually divide this table into two main parts to better understand how to use it. The left part of this table, spanning from the commodity column across to the maximum ceiling height, is related to our project specifications. This describes the actual physical conditions of the storage facility we are evaluating. The right part of the table outlines exactly what NFPA 13 requires us to use for our hydraulic calculations based on those specific project parameters. Regarding this table, we should note a few key points. First, these requirements apply to spray sprinklers. We should also keep in mind that NFPA 13 generally refers to these spray sprinklers as CMDA, or Control Mode Density Area Sprinklers, within the storage chapters. Second, for class 1 through 3 and for class 4, where the storage height is up to 10 feet, the table does not specify a maximum ceiling height. This means that regardless of the ceiling height, we are permitted to apply the design criteria provided in the table. However, for class 4, where the storage height is greater than 10 feet and up to 12 feet, the maximum ceiling height is limited to 32 feet. This means if the ceiling height exceeds this value, we are not allowed to apply the requirements found in this table. In these cases, we must utilize alternative protection strategies permitted by NFPA 13, specifically early suppression, fast response, or control mode specific application sprinklers. According to sections 22.1 and 23.1, CMSA and ESFR sprinklers are explicitly permitted to protect storage arrangements that require ordinary hazard or extra hazard design criteria, which encompasses miscellaneous and low-piled storage. Therefore, by shifting our design approach to use the criteria for these sprinklers specifically listed for the building's actual higher ceiling, we can safely and compliantly protect the space. For Class 4 commodities stored in racks with a storage height greater than 10 feet and up to 12 feet under a ceiling up to 32 feet high, the table provides two options for the sprinkler system design. One option is to use only ceiling sprinklers, while the other is a combination of ceiling and in-rack sprinklers based on section 25.2.1. If we apply the first option, the sprinkler system must be designed based on extra hazard group 1, with a total combined inside and outside hose stream allowance of 500 gallons per minute and a duration of 120 minutes. However, by applying the second option, the ceiling sprinklers are designed based on ordinary hazard group 2. This lowers the total combined hose stream allowance to 250 gallons per minute and the duration to 90 minutes. For this option, the in-rack sprinkler design must be based on the hydraulically most demanding 4 adjacent sprinklers, using a minimum flow of 22 gallons per minute from the most remote in-rack sprinkler. In general, where NFPA 13 provides a choice between a ceiling-only design and a ceiling plus in-rack design, applying the second option often leads to a lower overall system demand, even though it adds the challenge of installing the in-rack sprinklers. For example, assuming a rough estimation and ignoring minor and major losses, if we apply the ceiling sprinkler-only option, the sprinkler system flow will be 750 gallons per minute. This, plus the total hose demand of 500 gallons per minute, leads to a total system demand of 1,250 gallons per minute, which would necessitate a 150,000-gallon water tank to provide the required 120 minutes of duration. If we choose the second option, which combines ceiling and in-rack sprinklers, the ceiling sprinklers would be designed based on ordinary hazard group 2, requiring a flow of 300 gallons per minute. The in-rack sprinklers, based on the hydraulically most demanding 4 adjacent sprinklers at a minimum of 22 gallons per minute each, would contribute 88 gallons per minute. Adding the total hose allowance of 250 gallons per minute, the total system demand would be 638 gallons per minute. This would necessitate a water tank capacity of 57,420 gallons to provide the required 90 minutes of duration. Comparing these two approaches, we can see that the second option, which incorporates both ceiling and in-rack sprinklers, reduces the total system demand by approximately 50% and the required water tank capacity by about 60% compared to the first option, which relies solely on ceiling sprinklers. This significant reduction can lead to substantial cost savings on the water supply infrastructure for our facility, despite the added installation complexity. We just walked through the design options and hydraulic requirements for Class 1 through Class 4 commodities using the design criteria table. If our facility stores more hazardous materials like Group A plastics, rubber tires, or rolled paper, the process of finding our design criteria remains very similar. We simply navigate to the corresponding sections of the table for those specific commodities to find our required sprinkler density, hose demand, and duration. Now that we understand miscellaneous, let's look at low-piled storage. Just like miscellaneous, the criteria for low-piled storage are found in Chapter 4 of NFPA 13. However, there are some key differences in what it covers and how we classify it. Low-piled deals specifically with the storage of Class 1 through Class 4 commodities, as well as Group A plastics. The defining characteristic of low-piled is the maximum allowable storage height, and this limit changes depending on exactly what we are storing. If we are storing Class 1 through Class 4 commodities, our low-piled storage height cannot exceed 12 feet or 3.7 meters. However, if our commodity consists of Group A plastics, NFPA 13 restricts our maximum storage height to just 5 feet or 1.5 meters. Understanding these specific height limits based on our commodity classification is essential for properly classifying our storage space and ensuring our sprinkler system is designed to handle the hazard. For hydraulic calculations of low-piled storage, NFPA 13 provides a table similar to the one we reviewed for miscellaneous storage. Let's study the section of the table dedicated to Group A plastics. What is interesting in this table is that for rack storage, in-rack sprinklers are not required unless we have a solid shelf. It is important to note that NFPA 13 categorizes rack storage based on shelving design into open racks and solid shelves. Open racks refer to three configurations. First, racks without shelving. Second, where shelving exists, but the individual shelf area is 20 square feet or less, and the open gaps, what the standard calls flue spaces, between the loads are maintained. And third, where shelving, like wire mesh or slats, has at least 50% open area. This open design allows water from ceiling sprinklers to freely flow down through the racks to reach a fire. Conversely, solid shelves are defined by a shelf area greater than 20 square feet without proper flue spaces, or shelving that has less than 50% open area. Because solid shelves delay heat from reaching our sprinklers and block water penetration, they often require us to install in-rack sprinklers to adequately protect the lower levels of our storage. However, the physical structure of the rack is only part of the equation. We must also consider how we place our loads onto them. Even if we use wire mesh shelving with more than 50% open area, the boxes or pallets we place on top will physically block those openings. Because the load itself blocks the water, the gaps between the loads become our primary pathway for fire protection. This is why maintaining flue spaces is absolutely critical. Flue spaces are the clear vertical openings between our stored commodities. If we place our loads too close together and fail to maintain these flue spaces, which typically require a minimum clearance of 6 inches, the stored items effectively merge to create a continuous, impenetrable barrier. Let's go back to our design criteria table and study the requirements. For all types of Group A plastics, such as cartoned, exposed, expanded, or unexpanded, across all storage methods, NFPA 13 requires that our sprinkler systems be designed based on ordinary hazard Group 2 with 250 gallons per minute for the total combined inside and outside hose allowance for 90 minutes. When commodities are stored in open racks, we do not need to install in-rack sprinklers, as our ceiling sprinklers can adequately protect the commodities. However, if the rack uses solid shelves, we must install in-rack sprinklers. As we know, solid shelves delay heat from reaching our ceiling sprinklers and prevent the water discharge from the ceiling from reaching a fire below the shelves. Hydraulic calculations for the in-rack sprinklers are similar to those for miscellaneous storage. This means we must base our in-rack sprinkler design on the hydraulically most demanding 4 adjacent sprinklers using a minimum flow of 22 gallons per minute from the most remote in-rack sprinkler. In our previous section, we saw that for Class 4 commodities in open racks, installing in-rack sprinklers was an option that actually helped us reduce our overall system demand. However, when we deal with solid shelving, in-rack sprinklers become mandatory, which increases our system demand. This perfectly highlights why it is so important for us to store goods in open racks and maintain those critical flue spaces. As a final note, we should remember that when storage heights exceed 12 feet for Class 1 through 4 commodities, or 5 feet for Group A plastics, it is officially classified as high-piled storage, and our design criteria will increase significantly. In our upcoming videos, we will explore how to properly design fire sprinkler systems for different commodities and storage configurations.